compound. So we get two molecules of pyruvate along with this molecule. Now what is the fate of this pyruvate? What happens to pyruvate later on? So this pyruvate is then actually broken down in different steps, in different ways. One way is that this pyruvate may be converted to lactate using lactic acid fermentation process, or it may be converted to ethanol using alcoholic fermentation. Again, this pyruvate may be used for the amino acid synthesis like alanine and other amino acids. Now, for this aerobic respiration, the process that is used here is that this pyruvic acid, it is converted, it is used in Krebs cycle, and ultimately it gives carbon dioxide, water, and ATP. Now, how is it done? It is a stepwise process. So, the formation of acetyl coenzyme A from pyruvic acid. Now, you can see pyruvic acid or pyruvate, it is a 3-carbon compound, CH3, C-double-bond-O, COOH. So, this is pyruvic acid, which is in the cytosol. The first step is that this pyruvic acid, it is transported into this mitochondrial matrix using some transport proteins like carnitine, and then this pyruvic acid in the mitochondrial matrix, it is oxidatively decarboxylated. So there are two processes actually taking place. One is oxidation, second is decarboxylation. Decarboxylation means removal of carbon dioxide, and oxidation means addition of hydrogens. Removal of hydrogens. So the first step that happens here is that pyruvic acid or pyruvate, it is decarboxylated, means carbon dioxide is removed, and then it is oxidized. That is hydrogens are removed to give NADH, and then the third step is that coenzyme A is added to this pyruvate, and it is ultimately converted into acetyl coenzyme A. Now this acetyl coenzyme A is used in the next step of this aerobic respiration, which is known as Krebs cycle. And this Krebs cycle, we are going to talk about tomorrow about this Krebs cycle. So this is how this glucose is converted into two molecules of pyruvic acid, and then this pyruvic acid is converted into acetyl coenzyme A. Okay, thank you.